I don't know if love is the right word. It's a love-hate relationship. It's the fact that you're always wrong, which I think is probably quite fun, which is maybe that we're the only people in the world that we make a job out of proving ourselves wrong all the time. So that's very exciting, and that keeps you on your toes. We try and make new materials, so with our hands, so synthetically, that do interesting things within the realm of energy applications. So more specifically, we're working in an area called plastic electronics, which was a discovery about 20 or 30 years ago that plastics can conduct electricity. What we try and do is we try and make new solar cells, new types of TVs, new types of electronic devices out of plastic. When light hits stuff, your body or anything, there's lots of different things that can happen. One of those excited states is called a triplet, and I would like to hope that we've contributed something towards the learning of that. Globally, the field that we work in is one of the only possible ways to stop global warming and climate change. So it's, yeah, if we as a community get it right, it's probably quite a worthwhile pursuit. Having a broad spectrum of ways in which we generate electricity that is clean, that is efficient, that is renewable is extremely important. So within that framework, we try and offer a new set of materials which has new and different properties that can do that. So the benefits that our materials have are potentially that they are very cheap, they are very flexible, that they are printable, and so you can imagine a world in which you can print off miles and miles of solar cells, and you can cover a desert. So the types of things that we're interested in at the moment are, if you imagine plastic at the molecular level is just lots of long molecules, so lots of long wibbly chains of molecules. And how these come together in real life, in real space, is how they interact with each other, extremely important. And so what we do is we make new types of polymers, and we try and engineer those polymers synthetically such that we can control very precisely the interaction and the distance between adjacent polymer chains. Every single person has been so welcoming and supportive in particular. So when I started, my daughter had just been born, we'd just moved groups, and so basically we had to bring a whole bunch of people, and the whole thing was very stressful and very complicated. Everyone from the very, very top to the very, very bottom was extremely welcoming and extremely supportive. And that I didn't expect at all, because it was, oh, it's Cambridge, everything's very stuffy and terrible. And so there are bad elements in Cambridge, don't get me wrong, there's some very fundamental problems which have to be addressed, but at a human level and at a professional level, it's a fantastic place. In terms of group activities, scientifically, we have lots of discussions. We have some of those informally, some of those formally. So sometimes I just storm into the lab and say, oh my god, this paper's amazing, let's discuss it, what can we do, isn't it so interesting? And then also we have group meetings where people present and then we discuss their results formally. And sometimes that's either as very, very large formats, or sometimes we have sort of breakouts with different little sub-teams. Socially, we go for a drink when we can, we go to the park when we can. They do a lot of things now independently because I'm not allowed to stay out very late anymore. But I definitely think that enjoying your work environment is extremely important, and I would always try and encourage everyone to enjoy themselves at work, even if that means occasionally spending the afternoon in the park rather than at your fume hood.